will be our first use case of a robotic companion out on the airport environment for partnering with federal agencies on wildlife mitigation.
Alaska released robotic dogs at airports to solve a dangerous problem. But no one saw what was coming next. As Aurora, the robotic dog, patrolled the frozen fields of Fairbanks, it began revealing insights that went beyond aviation. Where we have to work very hard to make that safe for our people to work in. And so Dave the dog has been a fantastic innovation at making sure that we can hone the tasks we need to do, but we do that using robotics, using automation. What started as an experiment in safety turned into a story about adaptation, innovation, and a question no one thought to ask. What happens when technology steps directly into nature's territory? The sky silent threat. It happens in seconds. A flock of geese slices through the path of a departing jet, and 200 passengers are suddenly one heartbeat from disaster. In Alaska, this isn't a freak occurrence. It's a constant threat. Moose, foxes, and migrating birds wander freely across runways carved out of wilderness. Each takeoff is a gamble against nature itself, and sometimes nature wins. That's why in 2024, Alaska did something no one expected. It released robotic dogs at its airports, hoping they could finally do what humans and scare tactics could not. Protect the skies from the wild. But that decision didn't come from curiosity. It came from exhaustion. For decades, airport crews across the state have fought a losing war against the wilderness. Flares, sirens, decoys, even Remotech-controlled cars. At first they worked. Then the noise became familiar. The animals returned smarter and less afraid. Across the US, over 14,000 wildlife strikes are logged every year, and Alaska ranks near the top. In 2010, a small Anchorage plane hit a flock of geese seconds after takeoff. Smoke filled the cockpit. The pilot barely made it back. The message was clear. This threat wasn't going away. The pressure was on. Fairbanks International Airport sat at the center of the problem. Surrounded by open fields and nearby wetlands that attracted wildlife like magnets, airport staff patrolled daily through fog and frost, armed with radios and air horns instead of rifles. Yet, despite their vigilance, the issue kept returning as if nature itself refused to yield. The pressure was on and failure wasn't an option. Every incident, every near miss piled weight on the crews and the agencies overseeing them. That's when the Alaska Department of Transportation began exploring a solution so unusual that few believed it would ever leave the drawing board. But when the state finally released robotic dogs at its airports, no one, not even the engineers, expected what would happen next. What if the next wildlife ranger wasn't human at all? What if something could patrol the airfield that didn't tire, didn't freeze in -30 weather, and didn't flinch at the roar of engines? Something that could move like a living creature, but obey human control with absolute precision? Could a robot act as a predator and convince animals that the airport was no longer safe? By early 2023, frustration had turned into urgency. Each new near miss felt like a countdown to the day luck would finally run out. One report described geese nesting dangerously close to a taxiway, ignoring every deterrent attempt. Another recorded a moose wandering into the snow-covered runway lights at dawn, its shadow stretching across the cockpit windows of an incoming plane. Each close call made one thing clear. The risks were growing, and traditional methods were losing their edge. Alaska needed something that would change the game entirely. Then, from halfway across the continent, the idea began to take form. What started as a desperate proposal on paper was now turning into metal circuits and code. An experiment designed for industry was being refitted for the wilderness. At a Boston Dynamics lab thousands of miles from Fairbanks, engineers modified a four-legged machine that had once inspected oil rigs and traversed earthquake zones. Its purpose had changed, and soon so would everything around it. And if it worked, it could rewrite how technology and nature coexisted. By the summer of 2024, the plan was underway. A single unit was shipped to Fairbanks, reprogrammed, and given a new name, Aurora. The media called it everything from Alaska's mechanical ranger to the airport dog that never sleeps. To its handlers, though, it was simply the experiment that had to work. Standing roughly the size of a Labrador and painted with snow camouflage, Aurora was unlike anything Alaska's wildlife or its airport staff had ever seen. With cameras for eyes and sensors guiding every step, the machine could patrol autonomously or by remote control. Its mission was simple: keep wildlife away without harm. Its methods, however, would soon test the boundaries of what technology can and cannot do in the wild. Alaska had released its robotic dog, and now everyone was watching to see what would happen next. But once Aurora's metal feet touched the snow, the line between progress and nature began to blur. Enter Aurora. When the transport crate arrived at Fairbanks International Airport, few people on the tarmac knew what was inside. The label read Project Aurora. It didn't sound like something that belonged at an airport, but rather something meant for a space program. Inside, however, was no rocket or satellite. It was Alaska's newest employee, a four-legged machine that looked equal parts futuristic and uncanny. Aurora's arrival marked a strange turning point. The Alaska Department of Transportation and Public Facilities had been quietly working with engineers for months, preparing to test something entirely new in wildlife management. At first glance, Aurora looked like a mechanical dog made of yellow metal and carbon fiber, its four-jointed legs bending with eerie precision. But what made it remarkable wasn't its appearance, it was what it could do. Built on Boston Dynamics Spot platform, Aurora carried a high-definition vision system, directional microphones, and motion sensors that allowed it to detect wildlife even in blizzards or low light. Each leg adjusted its pressure independently, keeping it balanced on ice, snow, or gravel. Weighing 70 pounds and built for balance on ice, Aurora wasn't fast, but it was relentless. Its strength was persistence and unpredictability. The design team had studied how wildlife responds to predators. Birds and mammals are instinctively cautious around irregular movement, especially if it mimics a living creature. Aurora's designers took advantage of that. The robot's body panels were modified to resemble local predators like foxes and coyotes. One of its test configurations even included a tail-like attachment, swaying slightly as it walked. The goal was simple: make wildlife uncertain enough to stay away. The first demonstration drew a small crowd of airport workers, local reporters, and a handful of curious passengers peering from the terminal windows. When Aurora powered on, a soft electronic hum filled the air. Its legs shifted one by one with mechanical grace. Then it began to walk. The sound of its steps, metal pressing softly against the snow, echoed in the cold air. Even seasoned staff who had seen years of aviation technology stopped to watch. At the far edge of the runway, a small flock of ravens circled near a light post. As Aurora approached, they scattered in seconds. A few gulls followed. Within minutes, the area was clear. One technician laughed nervously, saying, "Well, it already works better than the sirens." Cameras flashed. The moment went viral within hours. Headlines appeared across social media. Alaska deploys robotic dog to patrol airports. But behind the excitement, the experiment was far from perfect. The robot needed constant supervision through a handheld controller. Its sensors, though advanced, struggled in heavy snow when visibility dropped below a few meters. Battery swaps were frequent. And at 70,000 per unit, there was one question no one could ignore. Could Aurora ever be practical? But Aurora was never meant to be just a machine. It was a statement, a glimpse of what happens when cutting-edge robotics meets one of aviation's oldest problems. To the engineers, it wasn't about replacing humans. It was about extending their reach. To wildlife specialists, it was a rare opportunity to study how animals respond to something truly alien. After the demonstration, as the crowd dispersed and the cameras were packed away, the operators guided Aurora along the perimeter once more. Snow fell quietly around it, flakes collecting on its metal frame. The robotic dog turned its head, scanning the empty airfield. In that silent moment, surrounded by wilderness and runway lights, Aurora didn't look like her equipment or a gadget. It looked alive. And in the days that followed, as it began its first official patrols, Fairbanks would learn that this experiment was about to take a turn no one had predicted. The first patrols begin. Days after the demonstration, Aurora's routine began. The crowds were gone, the cameras packed up, the headlines fading, and what remained was the quiet rhythm of fieldwork. Engineers and wildlife officers now watched from a control trailer instead of the runway, collecting data and waiting to see if the novelty would last. Almost immediately, there were signs of success. A group of gulls that typically perched near the approach lights took flight as the machine approached, startled by its movement. A few ravens followed suit, circling higher before disappearing into the sky. "That's exactly what we want," one wildlife technician said, watching the feed. "No chaos, just distance." The effect wasn't dramatic, but it was measurable, and that was the point. Over the following days, Aurora continued its patrols, alternating routes and times to study how different species reacted. The robot moved steadily, its pace deliberate rather than fast. It wasn't built to chase wildlife, but to unsettle it just enough to make the airfield an undesirable place to rest or feed. Biologists compared bird counts before and after each patrol and tracked activity patterns. Early data suggested a decline in animals near hydra areas, especially during dawn and dusk when flight operations were busiest. The biggest challenge, though, wasn't the animals. It was Alaska itself. Icy wind blew snow into the robot sensors, forcing occasional pauses while the operator cleaned the lenses. The freezing temperatures reduced battery life by nearly 30, cutting patrol times short. Aurora's legs sometimes slipped on hidden ice layers, prompting software adjustments to improve balance. Each issue became a lesson. If it can handle this place, one engineer said, it can handle anywhere. Inside the control trailer, screens glowed with heat signatures. Each small movement a pulse of life in the frozen dark. That same technology, they realized, could be valuable beyond wildlife deterrence, perhaps even for runway inspections or search operations. Aurora was doing more than its intended job. It was gathering data that humans couldn't collect as efficiently. By the end of the second week, Aurora had logged dozens of hours on patrol and hundreds of images of airfield wildlife behavior. While most interactions were predictable, animals retreating when approached, some situations raised new questions. Still, the experiment was showing promise. For the first time, airport staff had a mobile deterrent that didn't require explosives, loudspeakers, or vehicles. It could work in conditions too harsh for people and gather data while doing it. "This thing doesn't sleep and it doesn't get cold," said one airport manager. That alone makes it worth testing. By mid-inter, Aurora's presence had become part of the airfield routine. Pilots began referencing it in tower communications, robot patrol confirmed, near taxiway C, as casually as they would a maintenance truck. The novelty was fading, replaced by something more practical, reliability. What no one realized yet was that Aurora's biggest impact wouldn't come from what it scared away, but from what it revealed. The project was about to uncover findings that even its creators hadn't anticipated. But what came next wasn't malfunction or triumph. It was something stranger. Aurora was about to cross a line no one had planned for. And it would force everyone to rethink what success really meant, what no one expected. When Alaska released robotic dogs at airports, no one expected what would happen next. The plan had sounded straightforward. A four-legged machine named Aurora would patrol the airfield, frighten away wildlife, and reduce costly, dangerous collisions between animals and aircraft. For a while, it worked. Wildlife strikes dropped. Birds and mammals avoided the runways. On paper, the numbers looked good. But then, the project revealed challenges no one had seen coming. The first wasn't a malfunction. It was discovery. Aurora's cameras began capturing behavior scientists had never recorded before. Birds that had once scattered immediately began to linger longer at a distance. Some learned to return once the patrol ended. It works best when it moves unpredictably. One field biologist explained animals notice patterns faster than people think. To maintain effectiveness, operators had to vary patrol times, directions, and even Aurora's walking speed. What they thought would be a set-and-forget solution quickly turned into a carefully managed operation. The unexpected part wasn't failure. It was the data that came out of it. Aurora's cameras, intended to record wildlife avoidance, ended up capturing valuable footage of how animals interacted with human infrastructure. Migrating birds were observed adjusting flight paths depending on runway lighting and sound frequency. Foxes followed tire tracks instead of crossing them. Even small shifts in airfield lighting appeared to influence where animals moved. The robot became more than a deterrent. It turned into a research tool, quietly documenting how wildlife behaves in human-altered landscapes. No one had predicted that a machine built to scare animals away would end up revealing how they truly think. The team back at headquarters realized they had stumbled onto something bigger than airport safety. They began updating Aurora's software not just to scare wildlife away, but to learn from it. They experimented with audio deterrents, thermal alerts, and movement patterns that mimicked natural predator behavior more closely. Some days, the robot emitted low growls or flashing lights to amplify its effect. On others, it simply walked in silence, relying on its motion to unsettle nearby birds. Each variation revealed something new about how animals perceived threat, sound, and motion. The project's purpose had evolved from chasing wildlife away to understanding why they were there in the first place. Not everyone was convinced the experiment should continue. A few wildlife advocates questioned whether the robot's presence could disturb natural patterns. But on the runway, results spoke louder than theory. Wildlife strikes were down. "It's not a miracle solution," said one official, "but it's a tool that's working better than we expected." By March 2025, Aurora had become more than a machine. It was a researcher, a sentry, and in some strange way, a participant in the ecosystem it patrolled. Pilots casually referred to it as the dog. But to scientists, it had become something else entirely, a living experiment in how technology and nature learn from each other. That realization led to the next phase where every success came with new questions, dilemmas. By spring 2025, Aurora had stopped being a project and started becoming a paradox. The data proved it worked. Wildlife strikes at Fairbanks International dropped, especially among the large migratory birds most likely to bring down a plane. But the more it succeeded, the more it forced its creators to confront what success really meant. The results were mixed. Each patrol revealed a subtle change. Birds that once fled at first sight now circled wearily instead. Foxes began tracking Aurora's movements from the shadows. The wilderness was learning. The robot that was meant to manage nature was now teaching scientists how adaptable the wild could be. Inside the Alaska Department of Transportation, the question had shifted from, "Can it work?" to, "Should it keep going?" For airport crews, the answer seemed obvious. Aurora didn't sleep. It didn't freeze, and it didn't complain. But for biologists, the footage told a different story. The machine was beginning to influence the very behavior it was meant to study. "Every time we send it out," one researcher said, "the data changes a little. It's like the field knows it's being watched." That was the first dilemma. The second came quickly after autonomy. Engineers wanted to test an update that would allow Aurora to recognize animals on its own and react in real time without human oversight. Some saw it as progress. Others called it a risk. Once you give a machine the power to act, one field manager warned, you also give it the power to misjudge. Outside the labs, the debate grew louder. Environmental groups questioned whether a mechanical predator, even a non-lethal one, could distort natural behavior over time. Technology should assist nature, one advocate said, not train it to fear. Others defended the program as the most humane deterrent ever developed. No gunfire, no traps, no casualties. For the teams on the ground, those arguments felt far away. They watched the robot's slow patrols beneath the northern sky and saw something more practical, a bridge between the engineered and the instinctive. Yet even they couldn't ignore the feeling that each success pushed the line between control and coexistence a little further. One afternoon during a routine patrol, Aurora paused near the edge of the runway. Overhead, a flock of geese circled, not fleeing this time, but watching. For a moment, it wasn't clear who was observing whom. The wild, it seemed, was learning, too. And as summer approached, that line was about to blur again. Aurora's next phase, full autonomy, was set to begin. Autonomy. By midsummer 2025, Aurora was ready for its most ambitious test yet, full autonomy. At least that was what the team called it. In practice, it was closer to supervised independence. The robot would patrol alone while engineers observed from a distance, ready to intervene if anything went wrong. There were no press releases this time, just a small group of operators inside a control trailer at Fairbanks International, watching in silence as the program initialized. Aurora began to move, its sensors scanning for movement along the frozen perimeter. When a small cluster of gulls appeared near the approach lights, it adjusted course automatically. For the first time, it didn't wait for a command. "That's it," one technician whispered. "It's deciding." For several minutes, everything ran perfectly. Then, glare from ice scattered the camera's image feed, and Aurora hesitated mid-step, processing, recalibrating. It was a pause that felt almost human. A few seconds later, it continued its patrol. Over the following days, the robot completed a series of independent runs. It redirected itself around snow drifts, adjusted its pace in heavy wind, and occasionally paused in response to faint motion that didn't appear on the thermal feed. The data looked clean. The behavior didn't. "The system reacts faster than we can interpret," one engineer noted. "It's following logic we only partly understand." That uncertainty divided the team. To some, it was proof that autonomy worked. To others, it was a reminder of how easily a line can blur between precision and perception. One biologist put it bluntly. "It's acting correctly, but we can't say for sure why." By early autumn, the trial was declared a technical success, but the celebration was quiet. The thrill had given way to caution. Fairbanks had crossed the threshold between guidance and instinct. And on the edge of the tundra, under dim northern light, Aurora kept walking. An autonomous shape in a world that was suddenly paying attention. The future of living machines. By late 2025, Alaska's experiment had done more than prove a concept. It had started a conversation. What began as an effort to protect planes from wildlife had grown into a case study in how technology, once set loose, begins to shape the very world it's designed to manage. Aurora was no longer just a novelty walking across snow-covered runways. It was a working part of airport operations. Its patrols were still supervised and its systems constantly improved. But it had proven that robotics could play a real role in preventing wildlife strikes. The Alaska Department of Transportation called the project a qualified success. The number of reported wildlife incidents at Fairbanks International Airport had declined, and the data Aurora collected became valuable for both aviation safety and environmental research. Engineers had used months of feedback to fine-tune its software, improving navigation on ice, enhancing motion sensors, and adding self-flying mechanisms for its cameras. Each update brought the robot closer to full autonomy. Other airports reached out from the Rockies to Canada, asking if Aurora's success could be replicated. What had started as an experiment in one of the coldest corners of the world was now being discussed as a model for aviation safety in wildlife-dense environments. Still, even as Aurora's achievement spread, so did its questions. If a machine can change animal behavior, does it also change our relationship with nature? And if it can act independently, at what point does its decision-making cease to be an extension of human control? To the engineers, Aurora proved coexistence was possible, that technology could protect without destroying. To the biologists, it hinted at something deeper, that even artificial life once introduced to the wild becomes part of it. "We're not trying to dominate wildlife," one project engineer said. "We're trying to understand how to share space with it safely." Today, Aurora remains stationed near the main Fairbanks runway. Its yellow frame often visible against the white snow. On quiet mornings, airport crews still joke about giving it a parking pass or adding a badge to its metal casing. Yet, behind the humor is genuine respect. The robot has earned its place among them, not as a replacement for people, but as an unlikely teammate in one of aviation's oldest challenges. Whether future airports will release fleets of these robotic dogs remains uncertain. But one thing is clear. Alaska's experiment changed how the world views the balance between technology and the natural world. When Alaska released its robotic dogs, they thought they were controlling nature. No one expected that nature might start teaching back. Could robotic wildlife patrols like Aurora become a standard feature at airports worldwide? Or will nature always find a way to adapt faster than our technology? Let us know in the comments.